Physical Science, Chapter 27, Section 2. The main idea, Earth's surface materials can be eroded, transported, and deposited, therefore reshaping the land. Your essential questions, how do erosional agents such as water, wind, ice, and gravity shape the landscape? What are examples of different landforms created by erosion? And what are examples of different landforms created by deposition? Erosion is the removal of surface material through the process of weathering. Sediment transport is the movement of eroded materials from one place to another by either water, ice, wind, or gravity. And when an erosional agent slows down, in the case of water, wind, or gravity, or melts, in the case of glaciers, it drops the sediment load in a process called deposition. If you think of dropping your money into a bank, you're depositing it. Same thing. Running water. An important agent of erosion that exerts a downward force on slopes is running water. Drainage basins. In most river systems, small streams called tributaries flow into larger streams, which in turn flow into even larger streams. All of the land area that gathers water for a major river is just that. It's a drainage basin. As surface water flows downhill under the influence of gravity, water erodes the surface, creating its own path or following existing paths called channels. When running water slows down, it drops part of the sediment load it is carrying. The largest particles, obviously, will drop first. So if I have a boulder in one hand and a feather in another hand and I drop them at the same time, the one with the most mass is going to be the one that falls first. Floodplains are part of a river, but they are only underwater during floods. As the mouth of a stream that empties into a body of water, a fan-shaped sediment deposit called a delta will form.
Stream development depends on the slope of the ground over which the stream flows. Young streams flow down steep slopes in mountainous regions. Young streams often have waterfalls and rapids in a narrow, steep channel. The water flows swiftly and erodes the stream bottom more than the sides. In the mature stage, streams widen and flow more slowly down a gentler slope. Mature streams begin to erode the sides of the stream channel, developing gentle curves called meanders. The last stage of stream development is an old stream. Old streams flow slowly through wide, flat floodplains. Oxbow lakes are common in the old stage as the stream flows sharply back and forth across the flat floodplain.
A glacier is a large mass of moving ice. Valley glaciers form at the top or head of river valleys in mountainous regions. They move down slope, usually following the path of the pre-existing valleys. Continental glaciers, which occupy huge land areas, cover all but the highest peaks. Ice moves away in all directions under its own weight.
During the winter, in high mountain areas and in polar regions, large amounts of snow can accumulate. So much snow, in fact, that not all of it melts during the summer. Year after year, this layer of unmelted snow grows thicker. As the snow piles up, the increasing weight transforms the underlying layers into a hard layer of ice. This sheet of snow and ice is called a glacier. Under the heavy glacier, a thin layer of meltwater forms. The glacier slowly slides downslope on this slippery layer of water. The top of the glacier moves more quickly than the bottom, forming deep cracks called crevasses. As it moves downslope, the glacier scrapes along, acting as a slow bulldozer, pushing along rocks, dirt, and vegetation. This accumulated debris is called a moraine. Moraines form in the front of a glacier, along the sides, and sometimes down the middle, where two glaciers merge into one. After thousands of years, the climate may change. Temperatures may rise, less snow falls, and more snow melts. The glacier retreats back up the mountain, leaving behind glacial erosion features and deposits.
So as you can see, glaciers become effective agents of erosion as they move either downslope, as in valley glaciers, or under their own weight, as in continental glaciers. Valley and continental glaciers leave behind deep grooves or striations which give clues about the direction the ice was moving. Glacial ice exerts pressure to the sides as well, creating the distinct and easily recognized U-shaped valley. The removal of small particles by wind, leaving heavier particles behind, is called deflation. As wind speed decreases, the sediment load is dropped. The shapes and sizes of landforms that form depend on how constant the wind speed is and on the sediment supply. A longshore current occurs when waves approach a shoreline at an angle and are refracted. As waves change direction, they can create strong currents that move sediment parallel to the shore. As waves crash on the shoreline, they wear away rock and sand on the beach. As a result, constant wave action can erode the base of coastal cliffs. Waves can produce erosional landforms such as sea arches and vertical columns called sea stacks.
To understand what's happening, we need to start at the southwestern corner of Wales, in Pembrokeshire. This is one of the most exposed parts of the Welsh coast because the prevailing winds are from the southwest. Waves driven across the Atlantic smash against the cliffs, continually wearing them away.
The harder pieces of coastline, like this headland, only erode quite slowly, but the softer bits, like that bay, get eroded much more quickly. And it's this difference between hard and soft rocks that leads to the repeating pattern of bays and headlands.
Although these cliffs are all made of the same material, carboniferous limestone, the rock isn't uniform throughout. It has weak layers, faults and cracks running through it, all prime sites for erosion.
The erosion is due to several processes. There's hydraulic action, where the crashing waves compress water and air trapped in cracks, weakening and eventually loosening the rock. There's abrasive action, where material suspended in the water gets smashed up against the cliff face. And finally, there's chemical action, where the rock is dissolved by seawater and the rain. And just below where I'm standing is an absolutely stunning example of all these processes at work. This is the Green Bridge of Wales, a fabulous example of a sea arch.
If we go back 5 million years, the coast would have looked like this. First, the sea goes for the weak bands of rock. Then it goes for the cracks in the harder rock, forming first arches and then stacks. This leaves the Green Bridge as we know it today. It's easy to guess what will happen in the future. Not all stacks are formed this way. Sometimes they just get left behind as the coastline around them erodes.
Longshore currents move sediment along the shore. When this current slows down, sediment is deposited as offshore sand ridges or bars. Sandbars run parallel to the shore. Spits are sandbars that project into the water from land and curve back toward land in a hook shape. So we just looked at some pictures of sand spits. This is an example of a sandbar. Mass wasting occurs when erosion occurs primarily as a result of gravity, whether triggered by an influx of water, by earthquakes, or human activity. Erosion caused by mass wasting is dependent upon the type of event and the type of materials involved. For example, slumps, landslides, rock slides, or mud flows. Mass wasting events tend to deposit rock and sediment in disorganized masses.